All right, so reminder that this line right here, that is your given line. So this is the probability of F given E. And the formula is written right here. It's the number of outcomes common to E and F over the number of outcomes in E. So the probability of E and F, the probability of F given E just means that E has already happened. And if E has already happened, that may or may not have affected F. So that's why these are given probabilities. All right, so let's look at a couple. You are dealt a card from a 52-card deck. Find the probability of getting a heart given that the card you were dealt is a red card. All right, anytime that I have a given, that means that my bottom number, what I'm choosing out of, is changing. So normally when we're choosing a card, it would be out of 52 because there's 52 cards in the deck. But because they said, given that you were dealt a red card, I'm no longer dealing with 52 cards anymore. How many cards am I dealing with? 26. I'm dealing with half of the deck now, just 26. So now what is the probability of getting a heart given that I've got a red card? Do you remember how many hearts there are? It is half. There are 13 of each. So technically it's 13 out of 26, which reduces to a half.
Okay, so
It's real weird to think about.
we're dealt.
Oh, yeah, you are.
So we're dealt a red card, right? Okay. Okay, never mind.
It is kind of a weird thing it's a weird thing to think about. So the way I kind of look at it is it's almost like somebody dealt you a card and then like somebody else looked at it and was like, well, I'll tell you this, it's red. Well, that gives you a better chance of knowing what it is or whatever. So it's so weird to think about, I don't know, that you know something. You know that it's red, but you don't know what it is. I don't know, it's weird. Okay, number 2. Getting a red card. What is the probability of getting a red card given that the card you were dealt is a heart?
100%? All of them
100%. Because if you know that you have a heart, there's 13 hearts, but they're all red. 13 out of 13 of them are red, so it's 100%.
What? Hold on, wait a minute. So that doesn't.
Okay, so the first thing is you're given. I wish I had the little. Is it on here? The little deck of cards that they sometimes show. Was it on one?
No, that was just.
But as soon as they say that given that you were dealt a heart, you can completely eliminate everything but the 13 hearts. And then I have to ask myself, okay, what is the probability of getting red? And I'm looking at 13 red hearts. So it's 100%. All right, what is the probability of getting a jack given that the card you were dealt is a face card? How many face cards are there?
There's 3 different types.
12, right? There's 3 types, 4 suits. So there's 12 altogether. And how many of them are jacks?
4.
4. So 4 out of 12.
33.
Yeah, 0.33. What is the probability? A single card is drawn, but we are told the card is black. What is the probability that the card drawn is a king?
1 in 13.
Mm-hmm. It's 2 out of 26. So as soon as they said, we're told the card is black, I'm no longer dealing with 52 cards. I'm dealing with only 26. And out of the 26, 2 of them are kings. So it's 2 out of 26, which is 1 out of 13. Is everybody okay so far? All right, we've got a 2-way table. We had a 2-way table the other day. We just did straight up probability questions with them. We didn't do any givens, but remember, so our overall total is over here in the far right corner, 232. So I'm guessing that they sent a survey out or something. They surveyed 232 total people. So, but as soon as they say given, I'm no longer looking at the 232, I have to limit myself to the population that they've given me. So if one person is selected, find the probability that the person is female, given that the person is divorced. So that means my total is not going to be out of 232. What is my total going to be out of?
22.
22. So what is the probability that that person is female?
Which is
13 of 22. 0.5909, etc., etc. What is the probability that that person is divorced, given that the person is a man? So I'm not going out of my whole population. I'm only going out of men. So what's my bottom number going to be?
112.
Out of 112, what's the probability that they're divorced?
9.
9.
Which is 0.08, so 357. So
8, 3, 6. 3.
080.
0803. There you go. All right, is everybody okay? All right, I've got another. This time I have a two-way table. Look, and they do this on two-way tables. Sometimes they total them, like they did on this one up here. Sometimes they don't. So you might want to, because they might ask you. So I'm just going to go under here and total positive tests. There's 28 total positive tests. Negative tests, there's 72. Has the disease, there's 24. Doesn't have the disease, 76. All right. So 100 people were tested for a particular disease. If a person is selected at random, what is the probability of selecting a person who tested positive for the disease, given that they actually have the disease? So what's my number going to be on bottom?
20.
That they have the disease?
Yes, that they have the disease. So 24 goes on bottom. And what is the probability that they tested positive?
28.
They tested positive,
wait,
given
sorry,
that they...
Sorry.
20.
20.
Good. 5, 6. What is the probability that the person selected at random tested
Good
negative?
afternoon, Springtown High School. Please stand for the pledge.
Tested negative for the disease, given that they actually do not have the disease. So they don't have the disease, which means the number that I have on bottom is going to be 76. What's the probability that they tested negative? 68 out of 76. I don't even know where my calculator is. Somebody got it? What is that? Oh, there it is. 0.8947, etc. What is the probability that the person selected doesn't have the disease, given that they tested positive? So what's going on bottom?
The number of tested positive?
Yes.
So that's 28.
28 on bottom, and they don't have the disease.
That's 8.
Good. Very good. 0.2857.
I pledge allegiance to the flag